Good to go. All right. Hello, everybody. Thank you all for attending today. Really appreciate you being here. I know it's late on the second day. You're probably tired like me, but I'm excited that you're here. We're going to dive into today how open source can power the modern data stack, and I really hope to share some of the fundamentals of big data along the way. All right, so a quick agenda. We're going to start off with how data movement has really changed in our industry and how we've gone from what we would say is like the ETL model to the ELT model. From there, we'll dig into what the modern data stack actually is, as well as highlighting on a few of the key open source players and components. Then hopefully we'll dive into a quick demo if we have some time, as well as open the floor for a few questions. That said, a quick bit about me. My name is Ryan Bernstein. I am a data architect with Airbite. I've been in the big data world going on, better part of a decade now. And I've been at companies moving vast amounts of data. We're talking about petabytes each day. And oftentimes, I found myself the guy behind the scenes, the one who's spinning up the workflows, maintaining them, and really just working to keep the lights on. So when I came across Airbite, I knew it was onto something special. Airbite's been around roughly 2.5 years now, already has 30,000 users, almost 9,500 active Slack members. It's built this community of like-minded individuals who all want to solve for data movement. And as a data architect, unofficial maker of workflows, that really spoke to me. It's also where I want to kick things off today. So diving in, let's set the stage. To lay the groundwork on how data movement has historically been handled, you have to start with ETL, or something called extract, transform, load. But I want to introduce you to its younger, sexier cousin called ELT. Before we get there, though, ETL has been around the better part of half a century. It's a concept you all probably have used in the past. Maybe you're using it currently, but something I expect you're likely familiar with. The idea is straightforward. You run a particular routine to get data out of your application or your source. You feed that directly into your transformation engine. This means you create a tight coupling between your source and your transform. And it's at this point where you start to introduce what we call business bias or analyst bias into the data. You're modifying the data before it gets to your end destination. As the next step is you ship it off there, and usually that's, say, like a data warehouse. And at that juncture, that's where it gets shared with other people on your team, your company, and really the data gets consumed for its purposes. The problem, though, is that, like many other frameworks made half a century ago, ETL really hasn't kept up with the modernized landscape. It, firstly, and in my opinion, mainly, this is due to it being inflexible. If you have to make any changes to those pipelines, say you are adding a column, changing a data type, adding a new table or a stream, oftentimes that means you're back to square one, you're rebuilding that pipeline, and many times you're also having to go to the data engineering team. Those tend to be the gatekeepers of those workflows. And if you're not a data engineer, that means you're advocating for resources, taking time away from some other project. This bottleneck really reduces your own autonomy. Lastly, and speaking from my own personal experience, these workflows can be really complex. It can take a lot of work to keep them running, constant love and TLC to make sure that they're functioning as they should. And this creates tech debt for you and your company. So that brings us to ELT. The concept is not as revolutionary as, say, NFTs, but it certainly was a little bit more practical. It has arose really in popularity due to two things. Compute became super cheap, and storage also became super cheap. You can now afford to have way more data in your data warehouse than you ever could before. The idea is this. We run a generalized routine to extract your data, and then we feed it in its raw, unmodified state directly into your destination, again, commonly a data warehouse. The goal is to push the introduction of any of that business bias, that analyst bias, as far down into the data value chain as we possibly can, and bring the raw data as close to the users as you can. By doing this and pushing the transform to the end of the workflow, what you do is you create flexibility. Whether the consumer is an analyst, a data scientist, a data engineer, it doesn't really matter. They now all have access to the unbiased data, and they can customize it to their own ends. So, are you not sure what you need? The beauty is you can take it all. You can be greedy in how you use your data, and you can send it all into your data warehouse. This simple extract and load primitive allows for anyone on your team to quickly and efficiently spin up new pipelines, set up new workflows without the need to have to go through data engineering every single time that you want to build up a new workflow. That creates autonomy within your organization. And lastly, this really can help you future-proof your business. By putting the raw data in the destination, as your business requirements change, maybe you're pivoting, you don't have to rebuild all of these pipelines. Instead, all you have to do is change how you're using that data that you already have loaded. All right, so that was the quick primer. With that out of the way, we're going to dive into really what the main course is today. And that's how the open modern data stack can really work and function. So to kick things off, what we are seeing, and I'm sure all of you are too, is that companies are relying on data more than ever before. That's probably why you're here at this conference, maybe even why you're attending this particular talk. But for those who aren't, they're going to lose. It might be competitive advantage, it might be opportunities, but what we know is that data is going to pave the way. The thing is though, all these companies using data, they all do it in different ways. They all have these unique requirements that make up their own stack. For example, you could have a bank. Banks often work with highly structured financial data. Or maybe you have a content platform, and they work with media files or images. You could have companies who have huge data engineering teams. And for other companies, you might be the data engineering team. You have a fraud company that needs near real-time threat detection, or you have a B2B medical device sales company that is perfectly fine with overnight runs on their sales reporting data. The point is that with all of these splintering requirements and fractured needs, it's hard for one end-to-end solution to adequately solve for all of it. Thus, the open source modern data stack. The power of the modern data stack is that, in a lot of ways, it's like Legos. You can swap in and out the various components, allowing you to build the exact solution that you and your team need. And it just isn't about your requirements of what they look like today, but about what they're going to start looking like tomorrow, the ones you haven't even begun to start suspecting. There are a lot of aspects to the modern data stack. I wish we had time to get into all of them today, but that's also what makes it beautiful. Say you want to just kick things off and get started, maybe you just want a data ingestion tool and a data warehouse. But then as you grow, you want to move into adding transformations or a visualization tool. And then maybe after that, you would add observability. The point is, as your business and your requirements change, the stack grows and changes with you. And so you can continue to customize it and fuel your data needs. And the best part is, because you get to use all of these Legos, these individual components, you can always pick the best in breed solution for that particular requirement. All right, so I do have time to dive into, I'd say, 4 of the key open source players of the data stack. These 4, in my opinion, make up the backbone of the data stack. They are really the foundation you want to lay around your data warehouse. All right, so the first one, of course, is Airbyte. And for those who aren't familiar with us, Airbite is an open source data integration platform. You can download us from GitHub, you can have it up and running in the matter of a few minutes. We have over 200 connectors, many of them coming from community contributions. And I touched on earlier, we have an amazing community. We have 9,500 active Slack members, we have hundreds of contributors, and we've really built this community of individuals who care about data movement. But beyond the community, what Airbite has done is created a network of extensibility. This is really what I see as the power of open source. Open source allows for you to be flexible. It allows for interoperability. As we know, the world of data is changing, and we're able to address a vast number of use cases, not by focusing on the end-to-end solution, but by focusing on the building blocks, the Legos that allow you to build the bespoke solution that fits perfectly for your company's needs. A great example of this is what we call the Connector Development Kit, or the CDK. If there's a connector that you need that we don't have, or maybe you want to modify one that we do to fit your particular requirements, great, no problem. You can go ahead and do that. That's what the CDK is designed for. You can quickly spin up new connectors, you can modify existing ones, or it makes maintenance on the ones you've already built super easy. At Airbite, what we really want to do is we believe that data should be made actionable and available to everyone. And if that wasn't enough, we have this really cool mascot, plushies, so really what's not to love? All right, but before we move on, I'm going to dig a little bit deeper and take a peek under the hood here. All of this rests on the foundation of what we call the data exchange protocol. That encompasses the fundamentals of what it means to be transferring data. It is the lowest definition of what it means to move data from point A to point B. So things like, how do you handle schema management? How do you expose outputs? How do you transfer particular data types? With this protocol, you can build whatever type of Legos or connectors you want. As long as the connector fits within the spec, you can plug and play any source to any destination. And all of this coming together is what you see there in the orange. That's what we call the connector layer. And on top of that sits the platform. The platform handles things such as assigning connections, CRUD management, state configurations, kicking off jobs. For example, let's say you are replicating a particular data set you have. You're doing a Postgres to BigQuery, and you add one row to your database. You don't want to have to resync the entire database. That would be inefficient, costly, and it's not something you necessarily want to do. The platform is what's going to remember where you left off, what data has already been synced. It will keep mark of that and just pick up that new row and sync only that. But importantly, Airbite is designed to really work for all types of users. So if you want to version control your deployment, or maybe use YAML files, then you're going to probably want to use the CLI. No problem. Or if you are going to spin up 1,000 different connectors, you're probably going to want to use the API. You could also give me a call. I'd love to hear what you're trying to do with that. But if you just want a UI that you can log into, fill out text boxes, no sweat. The idea, again, is that we want to create ubiquity so that anyone on your data teams can create the reliable data pipelines they need to help you move your data. All right. Earlier, I talked about how there's the ELT. Airbite really focuses on the E and the L, so you still need that transform layer. And when it comes to the T, there really isn't a better solution than dbt. Not only have they effectively won the market, but they have brought the best practices of software engineering to the data world. They help you handle things like version control of your models, or how do you handle testing, or how do you package up your analysis and make it portable. dbt made these transforms accessible for a less technical audience while also still making them powerful and flexible. I can tell you at Airbite, our T is entirely dbt. Superset. So how do you think about enabling people who maybe aren't super technical, but are data exploration wizards? That is, oh, I went too far. Oh, there we go. All right. That is what Superset does. It allows for great visualization tools that sit on top of your data warehouse and allow for no-code visualization. This means your team can quickly spin up beautiful UIs, draw inferences, analyze data, all without the need to have to involve engineering. However, like the other tools we've been discussing, it provides the flexibility for more sophisticated code-based UI applications, again, addressing the full range of users. I think you're probably getting a trend here, focusing on the flexibility and extensibility. Lastly, we have Airflow. Now, one of the things you'll probably notice with this, and I know we've heard today, is when you have all of these individual components, it can be tricky to really get them all in sync and work together. It can be likened to a group of musicians who are all playing exactly as they're supposed to, but you still probably want a conductor to really just keep everybody in line. And that's an orchestrator. There are a lot of actually great open source orchestration tools out there. Airflow is one that we probably most commonly see. It hooks easily into Airbite as well as the other components of the modern data stack. Plus, it's also part of the Air consortium. You know, Airflow, Airbite, Airtable, Airbnb. We're bringing them all in. Anyways, make myself laugh. All right, let's take a step back, zoom out, and look at how all of this comes together. At the top of everything, you have Airflow. It is the puppet master pulling all the strings, telling each component when to kick off, what are the various states. So it's what would trigger Airbite to reach out to your sources. It would say, go to Salesforce, go to Postgres, grab this particular table, grab these new objects, and let's sync them with your data warehouse, BigQuery in this case. There, once they've landed, it would trigger DBT. DBT would come in, it would transform the data, get it into that end state that you can use to feed your other tools. So we talked about Superset. That would feed into Superset, powering those beautiful UIs you made, helping your team draw insights and really make that data actionable. Speaking of, actually, one of the items that I wanted to touch on is a new-ish trend we're seeing called reverse ETL. The concept is you have great data in your data warehouse. You maybe created a derived segment that you're really interested in and you want to action on that outside of your data warehouse. That's what reverse ETL does. A good example is maybe you created a marketing list of users in BigQuery and you want to get that into Google Ads. Reverse ETL. And there's some great players for this today too. High Touch and Census are wonderful examples of that. And it's also actually something that Airbite has been working on, and we hope to bring to the market sometime 2023. So we're really excited about that trend. Cool. All right, I'm going to jump into a demo here. I'm going to try switching off to my other laptop, so it might take me a second, and then hopefully we have time for a few questions. All right, so bear with me. Let's see. See? All right, cool. You guys can all see, right? Yep, good deal. Great. All right, so what I want to show you today is the platform. We talked about the open source and the cloud. I'm going to dig into the open source version today, largely because the internet here is terrible. It's really slow, and so the open source is a little bit faster. I have it loaded on my local. If we have the capability, we'll jump over to our cloud platform as well. But let's kick things off. So what you see right now is Airbite. This is running on my local. You have really three things here: sources, destinations, and connectors. So we will first set up a source. So you jump over to sources. You can see these are ones I've already set up. I can reuse them, and you can recombine them in countless ways. But we're going to set up a new one today. So I jump over here. This gives me a list of all of the sources I have available. I'm going to use Salesforce. We talked about Salesforce, part of that data flow. So we'll click Salesforce here. When you do that, it's going to give you a guide on the right-hand side that talks you through. For someone who's not super savvy with Salesforce, it gives you step-by-step instructions on how to pull all the information you need to reach into Salesforce and grab that. Most commonly, this is some kind of creds or token. Thankfully today, I have simplified that process. I throw it here into our vault. Let's pull up our Salesforce demo. Boom, that fills in everything, and we're gonna hit setup source. At this point, this is where it's reaching out to the internet, so fingers crossed, went quickly, and it's confirming that token I passed for it or those creds, and just making sure they're good before allowing you to advance to the next step. After this, it's gonna say, great, we have your source, now where do you want that data to go? We're gonna add a destination. So we can reuse ones I've already set up, but again, we're going to set up a new one. So let's go, same list. I'm going to pull up Snowflake in this case. Again, if you're not super familiar with Snowflake, our docs will walk you through it. It even provides commands you can run in a worksheet to set up user permissions and get everything needed, really designed for an amateur Snowflake user. I've already gone ahead. We also offer different auth methods, so OAuth or key pair. I'm going to use a username and password just because that's straightforward. And we will jump in here again, and let's fill everything out. Lastly, for most of our data warehouses, we offer various staging mechanisms. So if you want to just send it in directly, or if you want to first drop the files in an S3 bucket, a GS bucket, you have that flexibility. In this case, I'm just going to hit internal staging. We're going to just direct everything right into Snowflake. So same thing, hit setup destination, it's running, it's reaching out to Snowflake, it's checking all of the access I provided and making sure that that warehouse exists, those databases exist, that the username and password I provided are all good. All right, at this juncture, I have only a couple minutes left. I'm going to jump back. Juncture. This can take the longest part, particularly on a slow internet connection. This is where it's actually pulling the schemas. Salesforce has a ton of data, so our schemas are rather large. So while that's running, I'm going to jump over and show you the cloud. So, like I said, we're running on the open source. This is the cloud version. If you can spot the differences, good job. They're pretty small. The cloud and open source are nearly identical. The really only difference is on the cloud side, we host the infrastructure. You're not spinning up an EC2 or Kubernetes. We manage that for you, and you just come in, plug and play, and it's off to the races. But you can set up same sources, you can set up destinations, just like we're doing on the open source side of things. Let's jump back. All right, we're still fetching there. One of the other aspects we have, thank you, is that we want to provide a lot of resources. Again, on the concept of making this extensible, so it's open to a wide range of audiences, you click down here, we have all of our docs that designed, so you can set this up on your own, you can just dig into there and really walk you through everything you need to do. We also have great communities. So we talked about the Slack community, we have a discourse thread. You can go to all these places to help get questions, or get answers to your questions. All right, let's see. Beautiful. All right, so we have now fetched our schema. This, as you see, I'll jump into an example here, pulls all of the data that we can get out of Salesforce and pump over into Snowflake. You can probably tell there's quite a bit here. Salesforce has a lot of data. So rather than sending this all, I'm just going to focus on one particular stream or table. So let's hit that. And we can do bulk edits, so you don't have to worry about individually managing things. So I just deselected everything, and we'll focus on the account stream. That's one most people would care about, so hit that. We can hit this drop down here, and this will show you all of the different columns that we can bring over from Salesforce and deliver into Snowflake for you. We also outline all of the data types, strings, integers, arrays, so forth. And we're going to select how this data gets replicated. So you have some flexibility based on the data type, based on the source and where it's going. So here you can see that we have options of doing a full refresh overwrite. Think of that as like grabbing everything each time and just truncating those tables and dropping everything in again. Pretty expensive, not the most efficient. Or you have the incrementals, where we can keep a bookmark on where we last left off, what data has already been synced, what needs to be synced. And then you have incremental dedupe plus history. I liken that to like a CDC Lite. We also do support CDC for all of the major databases, but a dedupe plus history keeps all of your data effectively updated and matching the source in the destination. Let's say we want to do incremental append in this case. Great, so we have that configured. We come back to the top here. You see that we can define the replication frequency. So we offer out-of-the-box tools. In this case, it's going to run every 24 hours. We can run it every hour. We can define a cron and say run at 8 in the morning every morning. You can also trigger it to be manual, and this is where you can bring in your orchestrator. I talked about Airflow earlier. Airflow can trigger these jobs. It would reach out and read our state messages and be able to manage all of this for you. We provide a very simple orchestration tool. That way, if you're not using an orchestrator today, you're not limited. You can still just go ahead and get these kicked off. And that's the gist of it. So we have a basic here. Let's go ahead. Lastly, we do offer some transformation. So we talked about DBT. This is where you would want to plug in your DBT module. You would point to that. We would trigger it once that data has been loaded. We're going to skip that for now. We're just going to use a normalized data set. Bit setup connection. This is building the connection itself. And now that it's established, let's run into it, and we will actually launch it. So we're going to hit sync now. This is going to kick off that job. So this is spinning up the workers that are going to manage that data replication. And Airbite, transparency is really important to Airbite. It's a core tenet of ours. And so I'm going to pull up here. And what you'll see is we have full transparency into the data flow that's happening behind the scenes. You can pull these files, you can download them, you can programmatically get them via the API. But the idea is we want you to know what's happening and what's going on with your data. And so as all these steps are progressing, you can read through, and if there's an error, you'll see the error and what happened with it. But it really allows you to have full control of your data pipelines. Once it's done, we'll see a success message. It will say how many records are transferred. You'll be able to see that data in the M platform, in Snowflake in this case, and then that's when you'll be able to action on it. And that is, I think, really it. So usually these processes, depending how long it can take, it can be in a matter of a few minutes for small data sets or several hours for very large database replications. It just depends on really what you're syncing. And then lastly, you can see here, we have all the various connections I've set up in the past, as well as the other sources and destinations. So we manage that all for you. And then last bit, I talked about how Airbite focuses on extensibility. One of the things that I think really makes us special is our flexibility. We have 200 some odd connectors out of the box, but we have those custom connectors that CDK I spoke of, and that's where you could start bringing in over here. So you see this new connector, you could actually create your own connector, you would add it here, it would load into Airbyte, and then you can point to that. And so you can run your own custom connectors just like you ran any of the out-of-the-box tools. So with that said, I have only a couple minutes left. I'm going to jump back, and I think we're going to open it up for questions. So pop that back in. Cool. I think we have a mic. Do we have any questions in the audience? Yeah, let me run this down to you. I don't know. Is it on?
Are you able to hear me now?
There we go. All right. Awesome.
Yeah. So my question is with regard to automatically testing a pipeline. Can you actually mock any of those endpoints in this interface, or how do you, like, let's say, can you create a sandbox environment where you can actually test a full pipeline and and then repeat that, I guess, as often as you need?
Yeah, it depends. That's a great question. And so we do have testing built into the platform at various levels. So to go a little bit more granular, when you're building out connectors, we have unit testing built into all of that. And so you can define what happens when I'm expecting a string to be put, or like a date to be put in for a time, and someone puts in a string or something else. So we have those types of tests built into the connectors themselves. Some of the connectors also allow for sandbox testing. So we have we call it a faker one, where you can create fake data and push that into a fake destination. This Salesforce one that you saw has a sandbox option as well. So each connector is a little bit different. Some of them do enable sandboxing, others don't. But we do try to make that available where possible. So, thank you. Any other questions? Would you be able to pass the mic? Thank you. I think we lost you again. Is there a magic to the mic? There we go. Yeah.
Is it a way to automatically grant access to, for example, DBT users to the new data set is landed?
Oh, interesting. So you're saying you have pushed a new data set and you want to automatically also provision that out to particular users, say in like a BigQuery setup?
Yeah.
We don't have that today. I think that's great feedback. And so we're quickly iterating and moving. And I think that's something we would consider. So thank you. It's a great idea. Great suggestion. Would you pass the mic behind you, and then behind you when you're done?
Okay, my question is why we should use Airbite with a flow when Airbite already provide us like the orchestration, so we can run it.
We get that a lot. That's a great question. So let me rephrase that and make sure I understand it. So what's the difference between using Airflow versus Airbite? Yeah. So Airflow is an awesome tool. You can do a lot with it. What we find is particularly, oftentimes a lot of data engineers tend to over-engineer Airflow. They use it for things that it's not really designed to be used. I was also guilty of this as well. So what we recommend is Airflow is a wonderful orchestration tool, and it should be used for that. And we would pair it with an Airbite, which really is designed to handle specifically the E and the L. And you leave the orchestration up to Airflow. But a lot of our users are doing both. They either come from an Airflow model and they want to maybe harden their workflows, or they're looking at just adding more flexibility into it and using our CDK and adding more custom connectors. So it's a great question, though. Question behind? Yeah, if you could pass it behind you. With the mic. There you go.
Can you hear me now?
Yeah, thank you. Yeah.
What languages do you support for the custom connectors?
Yeah, wonderful. So we started, most everything was in Python. When Airbike got its start, that was how almost all of our connectors were built. We've actually been migrating to more of a spec file format, where it's more like language agnostic, kind of like more like a YAML file. The idea is we want to make it really accessible to create new connectors and also maintain them. Our goal is to get up to 800 different connectors, and that creates a lot of maintenance debt. So what we have developed is we call it the low-code, no-code development kit that allows you to go in and you just effectively say, here's an API endpoint, here's a data type I expect from it, it's an integer, it's a float, here's the various schemas, and so you can define it that way. But today you have options. When you download the dev kit, you can see that allow you to pick what language you want to work in.
Thank you.
So great question, thank you. I think we might have time for one more. Is there any other questions? No? All right. Well, thank you, everybody. Really appreciate you attending today.